Okay, here we go. I believe we are live right now. I trust my OBS. So, as stated in the description, today I'll be going over a couple of LeetCode problems, and also there is a LeetCode contest today. I've noticed that. I need to log in first. Will it? Yeah, perfect. I don't remember that. Let me just close this one a bit. Let me set this up. What's my password? Yes, I'm in. Let's go back. So there is a contest today, starts in 2 hours, so I will join to this one today. I hope we won't miss it, but before that we can just do some problems before that. Let me just open the comments from YouTube just to make it interactive. All right, so perfect. Let's start. I don't know, how should we go with it? Is there like a study plan? Yeah, I was actually doing a neat code 75 for a while, but I don't know, like this one, top 100 best rated. I don't know, it sounds scary, by the way. No, we can do this one, and I don't know, to make it yeah. We can start from easier to and come to the below. Let's go ahead. Let's see. non-decreasing order. Okay, so they're either increasing or staying the same, two consecutive elements. It's a bit tricky. Appending might be dangerous here, because append is, or am I wrong with that? I don't clearly remember the internals of this thing, this append, but let's see. So let's move forward with the nums1 and nums2. So here in this case, they are in a non-decreasing order. Wait, what? It's because they already, nums1 has a length of m plus n. Okay, so it's already has a certain shape. So if the length is 3, but the rest is not important. And then there comes this one. So here, yeah, here it should, oh, okay, there's nothing else there, so that's why. So if I iterates nums1 and j iterates nums2, yeah. So I don't know. How would we, maybe we can just like write down or work on the examples a bit, so it will be clear. So first you are pointing to this one. I will just make it a bit bigger. Yeah, better. So it's pointing to this one, right? I wonder if the screen is not okay. It's probably so. The first iteration, what do I want to see for the first one? It's taking a look at 1 and 2. Oh, 1 is smaller than 2, and perhaps we can move on to the second element there. So what's the question that I'm asking here? 1 and 2. Which one is smaller? This one is smaller. I would like to put the element here to this position and push this element to this position if this one is smaller than the corresponding element on this side. So here in this case, first it's 1 and 2, and 1 is smaller, so there's nothing that we can do for this case. We'll just move on to the next one. It's 2 and 2. Okay, so now it's an opportunity for us to put the 2 there. Or you can just say, for the equal ones, okay, we won't have any action. We will just move on, which makes sense. So we go to 3, and we have 2. So now we have we are obliged to update the array. So we will need to put 2 right now, and it will become what, like this. And the next element that we will be looking at, it will be 5 and 6. 5, sorry. And then where are we here right now? So we put this one to here. So the next, like the one that will be looking still on this first element will be 3. We'll be comparing it with 5. Okay, 5 is bigger, so let's move on to the next one here. So here at this case, you can either do the following. If you I don't know. I don't know what we are looking for. So here in this case, we are in a position that we've applied one thing, and m was 3, so m plus this change made it so we are it's 4, right? And we are at the index 4, so we can just copy whatever we have here to here. I don't know if this makes sense. I just noticed that I'm not that fast right now. Anyway, so here there's no element here, so there's nothing to update. You just return whatever the first array is. Here the important point is m is 0, and the index that you're looking at right now is 0. If you see this, that means whatever you have in the second element, in the second array, just copy it to here. Just make sure not to append or anything. Just update the single elements one by one at a time, because we don't want to deal with the space complexity that comes with the append, right? But yeah, let's go over to this one again. So imagine like you're just blind and you don't see the rest of the items, right? You're just only seeing 1 and 2. What do? You say, okay, 1 is smaller than 2. We can't put it in front of 1, so we have to move to the next element here. There, 2. We can put it in front, but it's okay. We will just wait for the next one to appear. And next one is m. Each time I think you're asking like, what is m? Is m plus the amount of elements that we moved to this part. Is it equals or bigger than the index we have here? The index that we're looking. So here it is, the index is 2 and the m is 3, so we are fine. But here we will check, look, we have 2 here, so we should put 2 here, and as a result this value should be propagated to the next one. But I think it's very it increases the complexity quite a lot, so I'm just like this propagating to the next one position seems a bit off, but I don't know what to do there. So here in this case we'll just put 2 here and we'll put 3 here, right? But imagine in the case of the following, we have 1, 10, 11, 12, 15, and 0, right? Maybe, I don't know, like 0, 0. Let's do it like that. And then we have 2 and 3. So we start with 1, 2. 1 is smaller, it's okay. We go to the next element. Oh, 2 is smaller, so we need to put 2 here. Okay, what happens to here? This will become 10. Oh, what happens to here? It will become 12, 11. Then this will become 12. Then we'll do this will become 12, 13. And then we move on to here. This one. We were here, right? We will need to put 3 here. So delete 3, delete 10, delete 11, delete 12, delete 13, and we're done. Which is which means you will be iterating over it a lot. Although I have another idea right now. Given that we know the difficulty of starting from the top to from the beginning to end, we can iterate from the other side, perhaps, right? We can just say, what is m? M is 3, so we should start from here, right? And the discussion becomes, which one is the bigger one? 6, right? Okay, let's put j point to this one and update this one to be 6. So 5 or 3? 5, of course. So 2 or 3? 3, of course. And 2 or 2? Whatever. Let's say we chose this one, right? And then it's empty, so it's already done. I'm actually happy with this approach right now. What happens with this example that we've gone over it? So here, what will happen is it will of course have right, 2 like this things here. So and m is 5, n is 2. So here in this case, first we'll check what is m. Okay, let's go take a look at the 4th index for the first array and the first index, like the second index basically, but doesn't matter. So just take a look at the last items. Which one is bigger? Okay, it's 13. Make this one 13. Point to this one right now, point to this one, continue to point to this one right now. Which one is bigger? 12. Which one is bigger? 11. Which one is bigger? 10. So now we are at this position, 1 and 3. Which one is bigger? It's 3, write it down. Which one is bigger? It's 2, write it down. And we just basically sorted it. I think I got it. We'll basically have I and j values. And we'll start from the, yeah, it should be like this. I guess it will do it. And what we point ij and I don't know, like setter. I want to say it's setter, but yeah. So it's basically this m plus n minus 1. So you will do the following while j is bigger than 0, because you're mostly doing y is bigger than 0, like equals or bigger than 0, we'll be putting whatever we have in the second array to the first one, right? And I think we can also make it clear that and I is also equals or bigger to 0, right? Just to make it explicit. So I'm guessing this should work, and then we'll start from, right? We'll check if nums2 j is bigger. I think, yeah, we can do it like that. It's bigger or equals to nums1 I. Let's put it to nums1 setter index. Alright, and then decrease j by 1, decrease setter by 1. Else, just put whatever you have here, just whatever you have in the first array, and increase 1. Setter should be also should be decreased, whatever you have. Just that I noticed right now, perhaps it can also be done here, and then later on, like either one of them will end right. Like I'm guessing, like for here in this case, for example, the m is 1, so I will be 0, j will be minus 1, so it won't enter here. We'll just return. Yeah, we'll just return it. Here in this case, it's m is 0, so it will not enter it into it. We'll just return this one, but that's incorrect, right? So it's only available for this condition. But in the end, we want to return nums1. So what will happen in this case? It will identify j as 0, so it will iterate once, and what it will do, it will check nums I is minus 1, right? So that's important. If there is no item there to be put, let me check. Yeah, I think if there, like, if it's like below 0, which means there is no item in the nums1 left, so you just put whatever you have in nums2, or it should be bigger or equal to nums1 I. Okay, and if there's something left, and it's smaller than and if it's bigger than nums2, you can just put the one in the nums1. So I think this will work. Perhaps we can run it first. So yeah, seems to be working. Shall we submit? Yeah. Bam. What's the solution? This is my solution. What's the these are solutions. This is editorial. Let's have a look at the need code merge sorted array. Need code 88, right? Is this the 88 one? Yeah.
With AI,
you can create any character you want in seconds.
This used to require huge Hollywood budgets, complex software.
Hey everyone, welcome back, and let's write some more neat code today. So today let's look at complexity.
Jeden Tag was Neues in der Volt-App. Essen, einkaufen oder dein Lieblingscafé. Mit Volt findest du immer.
Is big O of n. We also need extra memory. We need this temporary array. But is it possible to solve this problem exactly how they want us to solve it without actually needing this temporary array? Because if we don't need the temporary array, we don't need the extra memory. Then the memory would also be big O of 1. So let's see how we can solve this problem the most optimal way. Okay, so when you draw it out like this, the first thing you notice is that the empty space is at the end of nums1. So if we're gonna start merging these values, why should we start at the beginning and start like filling this way when it might just be easier to start filling this way if we want to sort it, because there's already empty space. We know that there's enough space over here for these elements to fit in no matter what, right? Like that's guaranteed. So I want to start merging from here. So I'm going to initialize a pointer here. This is where we're going to start merging. It's the last value in nums1. Now, what value do we want to put here? Since we want it to be in order, we want the largest value to be over here. How do we get the largest value? Well, we can start at the last real value in nums1 and the last the last number in nums2, because there's no empty space in nums2. And we can compare these two values. We see that 6 is greater. So we don't need this anymore, and we can replace it with a 6. And we also don't need this anymore, so we can move our pointer of nums2 over here now, looking at the 5. And we're also done with this pointer. We can shift it over here. Now we compare 3 and 5. We know 5 is greater, so that's exactly what these right minus 1. So the next thing we want to do is start merging them in reverse order. So now that we have all three of the pointers we need, last, m, and n, let's start merging. We're going to keep going while there are elements left in both arrays. So while m greater than 0 and n is greater than 0. We want to find the largest value. So if nums1 of m is greater than nums2 of n, then we can go to our last position, replace it with nums1 of m. The else condition is if they were equal or if nums2 was greater. So in that case, we just want to do the opposite. Nums1 last, it's going to be nums2 of n. One thing we should definitely not forget about is updating our pointer. So since we're going in reverse order, we're going to decrement m and decrement n. Regardless of which element we insert, we want to decrement last regardless. Case that we forgot about. Let me show you. So this value was a 2 and this value was a 1. What would we have done in that case? Well, we see that the 2 is greater, so we would get rid of this and then put a 2 here. But notice now how the empty elements are in nums2 over here, right? So in this case, what are we going to do? We're basically just going to take all the remaining elements in nums2 and then we'd keep taking each value. And we're so n and last are both going to be decremented by 1. And hopefully this is bug free. Okay, so this is actually not too bad of a bug. We remember that indexes start at 0, so we forgot to use the -1 in I think most of these, so let me not forget. And now it should work. Awesome. So I tried to make this code somewhat more like readable and beginner friendly. There are definitely more tricky ways you can do this. As always, thank you so much for watching. Please like and subscribe to support the channel. It helps out a lot.
All right. I mean, not a bad solution. Good. Let's. No, that one I did. I think we did. Well, wait. So we've done merge sort array, remove element. Apparently, I've did it before. What does that mean? You already solved this one in other place. I actually did quite a lot in another place. What does that mean? Yeah, I don't know. I can solve it again. shouldn't be a big problem. Okay. Mm-hmm. Look at input array. Expected answer with correct length. Correct length is k, or I don't know. Anyways, int k, remove closure implementation. Okay, so you're just in place updating it, and you can just ignore the ones beyond indexed. Yeah. So here you are going to move one, and yeah, just something there. Here this one will go, this two will go, this one will go, and this one will go. As a result, it will return this one. Sure. I don't know what's the best way to do that without moving a lot of things. Not sure at this moment. Yeah, but let's work on it over the example. Wait, oh. Let's work on it over the example here. I just want to make it a bit more zoomed in. Sorry for that. I'm just an old guy. So here, the duplicates, we want to remove the duplicates, and while keeping the ordering correct. So let's talk about the brute force, like the first solution that comes to my mind. I can go over it. If I see a 0, like if I see an element that is the same as the previous one, for example, here we will start from here. If it's the same as the first one, just pop it out, right? Just list.pop utility. So what it will look like this. Okay, and then our index will show this one. Is it like the same as the previous one? No, it's okay. Then move on to the next one. Oh, it's the same as this one. So then what do? We pop this one out, and it will become like this. So index will point this. It's the same as the previous one. Pop it out. Okay, this is fine. Move on. Okay, this is same, so pop it out. 3 to 2, they're fine. For 3 to 3, they're the same. Pop it out. So you have the new index list. What's the disadvantage? Yeah, what's up? Everything is good. Why, uncle? Right, we have the so what's the disadvantage of this approach? disadvantage is popping moves every element to the left, or I don't know, maybe it creates another as far as I know, yeah, I think it pops it out, this element, so it moves everything to the left. Python list pop complexity, we can call it. Yeah, the shifting of it creates the issue. Shifts every element to the left. Basically ON complexity. But what is the alternative way then? Like, how can, what's the problem is, then can we start from the right to the left then? So we can check if this one is identical to this one. Okay, it's not, move on. If it's identical to this one, yeah, it is. So we need to pop this out, and we will need to shift this one right as well. Or perhaps yeah, difficult. It's funny. All right, so this one will go, and then this one will identify it as self, as a duplicate. But like, actually you're shifting the elements on the right to the left again and again and again. Like, I don't see the disadvantage being solved here, to be honest. Either way, if you're popping things, you're just shifting everything. But what is the other way instead of shifting anything? Like, it is still expected to be in memory, right? You want to move this out, move this out, move these two out, move this one out as well. What if you not pop it out but do something else? Like, you can start from either direction, doesn't matter. You have it here, you will identify as this one as duplicate, this one is duplicate, duplicate, and this one as well duplicate, and this one as well duplicate. So in this case, would you be able to, I don't know, so this one needs to be, you know, populated with the next value here, right? That one you can do, just replace this one with the next one over coming here, so it can be, so this one will be going here, this one will be this, so here you will just have a look at the next one, so it's 2, let's replace it here, and this one will be 2, so we are looking at here, here, put it here, then put this one to here. So you're iterating the list again, But that's it, you're not shifting everything and stuff. So I think this is the solution. First you are just iterating over the nums list, and you can perhaps iterate from the first index and then just check if nums I equals to nums I minus 1. Please make nums I or like sorry, I minus 1, yeah, I minus 1 as this. I don't know, these are all integers, right? Nums, yes. So make it this. And then you'll continue iterating. So this adjusts the list first, and then you'll have you'll also again iterate over it, right? You can put I and J. They can both start from the first one. So the thing that we want to do is the following. So we've labeled this one, oh wait, not this one. This one as empty, this one as empty, this one as well. So here we made it empty, and here we made it empty. So here from now on we want to fill from the left to right, right? You can either call like start, or I don't know, like I will point out the things that we'll set. Yeah, let's call setter and reader. And basically while reader is Dankeschön. Saygıdeğer hocam. Len nums. Do we have this number? No. Yeah, while reader is within this list, we'll iterate, right? It will iterate to the right, and if nums reader is this empty value, we'll set the value with that. As a result, we'll increase the setter by 1. So how it will go, they're both pointing out to this, and the reader is 0, and then nums is here, it's 9. It's 0 is smaller than 9, so we enter into this loop. If nums reader, which is 0, the first points to the first element, is it equals to this? Yes, so it will not enter into this part of the conditional, it will go on to the next one. And then here it will check, oh, it's actually a number. It will enter here, and it will set this one with the value of 0, so it will be this. And then it will move on to here. Nothing will happen. Nothing will happen. Here it will see and put it to here. It will move on. Nothing will happen. Okay, it sees this, it puts it here. It sees this and puts it here. And it sees the 4, it puts it here. We can actually return this array because the code will be checked for only the first elements. And in the end, what do we want to return them is the setter information. Why? Because setter at the end of it will point out to this index, and this index is number 5, which also represents how many items, how many unique items that we have here. So returning the setter should work fine. Let me just review everything by removing these things. As I said, first loop iterates over the nums starting from the first element, and it always checks if it's the same as the last element. If it's the same, it changes the value of the last element. And then we have setter and reader, and if there's a number that is a read, we set it up with the setter, and then in the end we return setter. It should be fine. Let's run. Let's submit. Okay, yeah, worked. I think it should be the optimal one. Maybe there are like some fancy solutions. Is it? Lol. Use 2 pointers coding. Is it? Nah, forget about it. Let's move on to the next question. Now each unique element appears at most twice. Okay, this is the same as the last one. Return k after placing the final result in the first k slots of num. Yeah. Do not allocate extra space for another array. Okay, thanks for the tips. Okay, I think it's straightforward, but let's work on the example. So here we were starting from the previous example. We were starting from the index, the second index, and we were checking with the previous one. If it's identical, we were removing the first one so that we will always have only one single unique element. Here in this case it was a bit different. We can have duplicates, but at most 2. So yeah, only duplicate that can appear is only 2, not 3 times. So here there are 3, right? 3 identical elements. So here in this case you should check at each part. Perhaps you should start from here and the third index right now in this iteration, and you should check if the previous 2 elements are identical. If they are, then I will, I don't know, make this one as this one, and then I will move on to the next one. Is the last 2 identical with this one? No. Move on. Last 2 identical with this one? No. No. And we're done. So this was the first iteration. Then in the second iteration, what we do is we use the setter and reader, right? And then whenever we read a number, we set it up. So it will go like 1, 1, 2, 2, 3, 3. Why do we have 3 here? Because we don't, like, the execution will follow this, the implementation. And as the question says, just return k, like how many elements that you identified, which is 5, right? And it will only check the first 5 slots. So it will be straightforward. Start from the third index. I'm not sure if I'm able to do that, but let's check. We can learn from it. This was the first iteration. And the second iteration is happening by setter and readers. Initialize to index 0, while reader is nums. If nums reader is not this, it will just set nums setter with the nums reader, and then we'll increase the setters by 1. We also need to put reader in any case to the next iteration, and then we return the setter as num. It represents number of unique values, not unique, but like, yeah, number of elements that will return. So this should do if this one works, but let's see. Yes, but this is not a proper test case. It is. All right, this one is also success. Next one. So it's floor n-2 to the floor. So it's, if it's n is 3 here, it should happen more than one time, right? For here, it's 7 elements, so it should happen more than 3 times, basically meaning more equals to 4 or more, which is fine. Straightforward. Okay, there will always be a majority element in there, right? And could you solve the problem in linear time and in O1 space? Linear time means you have to, basically ON, time complexity, which means you need to touch every element once, twice, or 3 times, or 10 times. Doesn't matter, but it's not, you're not touching it in an exponential manner, okay? To summarize it. And O1 space means you won't have any big data storage. You'll just have nums or 1 or 2 variables and stuff. Oversimplified explanation. Okay. Okay, so majority element, you want to count it for 3, 2, 1, 3, 2, 3, this one. How would you do it? I mean, when you look at it, it makes sense. It's very visible, but the computer is only seeing one element by one element, so it will only see x right now, okay? So you only see 3 right now, and you can perhaps store it somewhere. 3 appeared one time, and then it will see the other one, and it will forget about this one, which will be 2. Okay, update your memory. 2 also appeared once. Next element, it's 3. Okay, 3 appeared 3 times. So here then you can have a look. Given my memory, I can check that 3 happens 2 times. Okay, it is the max element. Majority, it is the, yeah, it is 2, and it's bigger than 1, so I must return 3. You can do this. So you'll just iterate over whatever you remembered. There's one problem though. There is one problem though. This is requiring an additional memory space because of this. Is there a way that you won't have any other space, any other variable, so that you can just go through it one by one, right? You will just read 3 or 3. Okay, this one appeared. Is there a, there's always a majority element existing in the array, and the linear time complexity. The majority element. There should be a way. Like you see 3 and you have to remember it somehow, but how can you remember if you don't have any additional space? Perhaps you can move forward it to the next one, so you will just remember the last element was 3 and you will see 2. You can, I don't know, you can also remember 2 perhaps, but it's just remember 1 or 2 things. I don't know, maybe you can choose to remember 2 and it will be 3, and then oh, it's gone. Yeah. I'm missing something. So here, what do I see? I go through it, 2, 2, 2, 1, 1, 1, 2, 2. I can put it into a dictionary to remember how many times they appeared, but the problem there is you are having an additional storage. The additional storage is for representing, but you don't need to remember all frequencies. You need to just remember what is the majority. And that's the difficult part, the majority. If there's always a majority element existing in the array, what does that mean? One element will appear quite a lot. Yeah, more than the half of the times it will happen to exist. You don't need to remember how many times it existed. You don't need to remember about anything actually. Just this value. I really don't understand. So when I look at this element, what I do, like, I don't immediately see it, right? I just count it by myself. I count like 2, it happens 1, 2, 3, 4 times. This one element happened 4 times. And then I would go on to, okay, this we counted. This, I like intuitionally I go as the following. I check how many unique elements they have, 1, and 2. I would go over each one and check how many times it occurred. It's 4 times. Okay. But the problem here is like it wouldn't happen in the first try. Perhaps it can happen. Like imagine this was 1, 1, 2, 2. In this case, you will just remember all the things. 1 and 2 is the unique values. Perhaps it can have 3 here, 4 here. So it's like 1, 2, 3, 4, right? And you start 1 how many times? 2, 4 how many times? 2 how many times? And the complexity becomes 1 square. For each element, you're just scanning like in the worst case, for each element you're scanning the whole table again and again and again and again. I don't understand. Sun is up. Move your body. I don't want to look at the discussions. Oh, 1 space. I mean, how come? I don't understand really. I apparently solved it at, I don't know, previously I apparently solved it. Now I don't remember the solution. I feel like there has to be a way that you're scanning this list, and if you were to sort it, yeah, I don't. Hmm. You can change things in place, right? You can make it. You can change things in place, right? You can say, for one, oh, I don't know. For one, 4, 2, 2, 3, 2, 2. I'll get a hint. There is no hint. Really? Why? Sorting. What? Sorting? What? Linear time. Sorting. What? Really? What do you do here? Divide and conquer. Hash table? What? What? Dude, counting, yeah. Sorting, I'm not sure about that. Divide and conquer, okay. Sounds like... I forgot the quick sorting. Could it be like that? Sorting is n log n. But is there something that makes it n? I mean... no idea. Oh. No, wait, not like counting. Um. have to look at it. Boyer-Moore majority vote algorithm. Majority vote. There is a majority that voted fit the requirement is to use bit manipulation.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem majority element. I probably should have solved this problem earlier, but don't let the tag fool you. It's easy because the simple solution is actually easy to implement, but there is a follow-up that's not very easy to come up with. So we're given an array of nums of size n, and we want to return the majority element, and the majority element is defined as being the element that appears in more than half of the array. So for example, we have 4 elements. Let's say we're given an array of 4 elements. That means there's guaranteed to be a majority element, an element that appears in more than half of the array. So in this case, there has to be an element, let's say it's 1, that appears for 3 values in this array. It could even appear in every single value possibly, but not necessarily. So we could have, let's say, a 2 in the last position. So in this case, we would return 1 as the majority element. So the easy way to solve this problem is basically implement it as if we were finding the most common element in the input array. But to actually solve the follow-up question, we will have to leverage the fact that it's the majority element, not just the most common element. But for now, let's focus on the simple solution. We're given some values. We want to know what's the most common value. The best way to do that is to count the occurrences of each value. What's the best data structure to do that? Sometimes you can use an array, but if you're given arbitrary values, like these values could be in any range, let's say, the best way to do it is with a hash map. The reason we're using a hash map is because we can have any key value. We can use any integer that could be in the nums array as the key value, and the value in this case is going to be the count of each number. So n is going to be mapped to the count, and we can do this operation. Any operation on a hash map is an O of 1 time operation. So we can count the occurrences of each value in big O of n time just by iterating through the entire to code. Okay, let's code up the hashes of each. Then is getting already was. So that's the entire code. Last thing we have left to do is actually return whatever the result was, and let's run it to make sure that it works. And as you can see on the left, it's pretty efficient, but there is one improvement that we can make to our solution, and that is getting rid of the hash map. And just to let you know, it is kind of difficult to come up with this algorithm that I'm going to show you. It's actually named after, it's like an academic algorithm that's named after people, Boyer-Moore algorithm. So don't feel too bad if you weren't able to come up with it yourself, but it actually is very easy and simple to implement once you know it. Let's just take this array on the right. What if we just tried to maintain one max and not use a hash map? Would that work out for us? Well, we'd look at the first value, 1. So we've seen a single 1 so far. So it's our max currently. And then we see a 2 value. So now there's a single 2 value. So these two are tied for what the max is. Well, 2 variables isn't so bad. That's doable, but there could be a ton of values in the input array. Next, we see a 2 value, so there are two 2 values. Next, we see a 3, so now we got to start keeping track of 3s because 3 might become the maximum. Now there's 2 3s in here, so these two are tied for what the max is. So maybe we're not even looking at the 1 anymore, but then there's 2 more 1s, so there becomes 3 1s, and then 1 becomes the maximum. It's not possible if we're counting the occurrences of every single value to keep track of what the max is. But the good thing here is we are guaranteed that there's going to be a majority element, meaning that take this array, for example, there's going to be a value that appears in more than half of the array. So we could have 4 3s in an array of size 7. And that fact that one number in here is going to appear in more than half of the array is essential for us to solve this problem in O of 1 space with linear time. The idea that we're going to use is going to be similar to what I talked about a moment ago. We are going to keep track of what the maximum is, and we're going to do that with just a single variable. So we're going to take the first element in this case, it's a 2. So we're going to set our result equal to 2, and we're going to keep track of the count of what the result is. So far, we've only seen a single 2, so we're going to say our count is equal to 1. So next we visit the second value. It's also a 2. So the obvious thing to do here is just to increment our count because the result is the exact same. So now our count is going to be 2, same result. Next we see a 1 value. So what's the intuitive thing to do here? Well, this is the first 1 that we're seeing. We don't necessarily know that, but we know that our result currently is 2. It occurs 2 times, the count of it is 2. So we might see a bunch more 1s. 1 might be the majority element. How will we know that 2 is not the majority element anymore and it's been overtaken by some other number? Well, we can, every time we see a value that's not 2, that's not our current result, we can decrement the count. And once the count becomes 0, and at that point we will know that maybe this is not the result because we've seen an equal number of 2s as we've seen other numbers. Therefore, it might not be the majority element. And the important thing is, what is going to be the result at the end of the array? So let's continue with the algorithm for now. If you don't quite understand it, I think you will by the time we are finished with this. So we see a 1. Now we're going to decrement our count by 1. So now our count is going to go down to 1. We saw a value that wasn't the result. Now we see another 1 value. So we're going to do the same thing, decrement our count now to 0. Right at this point, we don't know if this is actually the result anymore because the count of it is 0. That means so far in the array, at this point, we've only seen 4 values, but this is definitely not the majority element in the first 4 values. But let's continue. We don't know what's going to happen. We see another 1 value. Well, at this point, we've seen more 1s than we've seen 2s, and we kind of know that because our count right now is equal to 0. So we can go ahead and decrement this by 1 again, which will put us at -1. But that doesn't really tell us anything about this result. That just tells us that this value occurs less than half of the time in the first 5 elements of the array because its count is -1. So a better thing to do would be to actually reassign the result. So now the result is no longer going to be 2 because its count is already 0. and we found a value that's not equal to 2. We found a 1. So we're actually going to set the result now to be 1, and we're actually going to update the count now to be plus 1. So meaning this value 1 has a count of 1, and all that means is that this might be the majority element. And right now we know that actually in the first 5 elements, this is the majority element. 1 is the majority element, but you're probably wondering, it could have been different, right? We only looked at the first 5 values so far. 2 of them were 2s, 3 of them were 1s. But what if the last one over here wasn't actually a 1? What if it was actually a 3, right? You might be thinking, well, isn't this algorithm wrong then? Because in that case, our count would have still been 1, but our result actually would have been set to 3. And what if the algorithm stopped here? What if these 2 values didn't actually exist? Then we would end up returning 3 as the majority element. Isn't that wrong? Well, yes, you're right, that is wrong. But what's also wrong is actually the input array. Take a look at this array. We have a 2, a 2, a 1, a 1, and a 3. This array actually does not have a majority element, right? And that's what this algorithm depends on. There has to be a majority element. So you might have a lot of questions, but trust me, this algorithm does work, and we'll explain a little bit more at the end. So at this point, we've reached this 2 value over here. So what are we going to do? It's not equal to the result, and our count is not 0 at this point. So what we're actually going to do is decrement this by 1. So now our count is to 0. So what that tells us is this 1 does not occur a majority of the time in the first 6 elements. Next, we see the last 2. And since our count is 0 and the 2 value is different from our current result, we're actually going to update the result right now, set it to 2, and increment the count and set that equal to 1. And at this point, we have finished the entire array. Our result is 2, so we're going to end up returning 2. So we actually got the correct value. That is the majority element in this array. But you might just be wondering, how exactly did it work? It kind of feels like magic. Maybe there are some test cases where it won't work. And I'll tell you that as long as the test cases are valid, as long as there exists a majority element, this is always going to work. And if you have a hard time seeing why exactly that is, try just taking this example array where 2 is the majority element and 1 is the non-majority, but these 1s could be anything. It could be, some value like 3, or it could even be multiple values, right? It could be a 3, a 4, a 5. It could be anything. But think about it like this. You could rearrange these 2s any way you want, and the algorithm will still work. You can try it. You could have alternating 2s and then the non-majority element, right? Something like this. And in this case, we'd say, okay, plus 1 to 2, minus 1, plus 1, minus 1, plus 1, right? At that point, we'd see 2 is the majority element. It occurs a majority of the time. We could swap these around. We could front load the non-majority elements, right? We could have a 1, and then have some 2s, and we'd say, okay, minus 2, plus 3, because we know that the majority element occurs more often than the rest of the array combined, right? So we'd see that this is the majority. You might start to see kind of why, right? This is the intuition behind it, because it occurs more than half of the time. That's very important. That's why this algorithm works. Now let's code it up. It's pretty easy to code. So this is our...
Yes, implementation is not difficult. All right, very interesting. Very, very interesting. I don't know, let's take 0 and 1, right? For I in range from 1 to nums. Equals res, count plus 1, else count minus 1, if count is less than 0 at the moment, just update it with the new one. The rest should be the latest one, nums I. Count should be 1. So perhaps you can do it like this. If it's like equal to, okay, if it's not equal to, you can check count 0. Alright, if it's like 0, you should make the count 1 and rest should be the nums I. okay? Else, if it's not 0, but it's something positive, you'll just decrease the count by 1. That's it. The only time that you change the result is when these two values doesn't match and the count is 0. Here you will just change it with the new value. Other than that, you will just decrease it. And at the end, it only asks us for the result. Very interesting algorithm. Very, very. But wait, the nums can be, okay, at least one element, right? Okay. Yeah, sure, submit. Very interesting. I wouldn't have guessed this one, but yeah, let's move on. There's a rotation array. I apparently solved it as well. Given an array, integer array, rotate the array to the right by k steps. Yeah. So 1, 2, 3, and then the rest comes to the front. So for this one, first you iterate every element to the right. So 1 goes to here, 2 goes to here, 3 goes to here, and 7 can't go nowhere, so it has to go back to the front, right? And then you will be doing it same, one more, and then you're expected to read nothing. You're just expected to update the nums. Should you do it for I in range k, or should you do it more smarter approach? So for k, so for example, for this example, we can identify which place that it will end up, right? So if k is 3 here, what happens? So this one has an index right now for 0. Then if I move it to 3 times, 1, 2, 3, it will have an index of 3. So basically every element will go to the side by k times. But in case of overflow, we need to have some kind of modulus, and the modulus will be len nums. So for here, for this element, its index is 6, and it should end up 1, 2, 3. It should end up in 2. So 6 to 2, right? Is it possible? So as I said, it will it should go old, new. Yeah. So the old one is this, and new one is this. So it should match right now. 6 plus 3 modulus 7. Does it match? No, it does not. So probably you have to have some -1 here, just to, oh wait, it actually, no, 9 modulus 7, 3. Yeah, so it should work like that. So minus k, minus 1, sorry. So for each element you will be doing that. For, I don't know, let's do it like this for I in range. But where you should start doing it, you don't want to override it, right? For example, if you start from here, you will update this one, right? And this one should go to here, 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 and we're done. Apparently it will handle itself, because yeah, while you'll start from I0 and you can start from there. Then we will start it, and the value will be nums old index, right? You want to start it, let's start it like this, and we'll say just nums new index, assign it to temp, alright, and nums new index should have the value of the old index. Nums yeah, right now, then you'll return back. You're not swapping something, you're just assigning. And then I think old index will change to be new index right now, and the new index will be here, coming from here. And what you want to have, you will go like this for a while, but you need to have some kind of exit condition. That I'm not sure right now. It should I believe by design it will come up to the first point. So I think like it goes from this one here, this one goes 1 to here. Oh, okay. A mistake. Kanka yardımcı ol ya. Yardımcı ol kral. Help me. Oh. Okay. One option. I can actually do the following. Okay, this strategy will be correct, but I can also do starting from the left to the right. Okay. For this one, I will go to this one, right? So what I will do is I will make this one 1 and 4, and I will move on to the next one, and this will go to 2 5, make it 2 5, and then this will go to here and it will make it 3 6. The right element will mean the old value, okay? And this one is already changed, this one already changed, sorry, it's already changed, but it needs to be updated. So this this will go back to 1, and it will go, the 4 will go to 1, 2, 3. 4 goes to here. And next one, this one, 5. 5 goes to here. Like this. Right. Sorry, the old value needs to be on the second one. And this one, 6 goes to somewhere else. 6 goes to here. And seven goes to here. But the trick is, when you're overflowing, you just don't set it up as a tuple, just set it up as once. And that way you're guaranteed, basically, to, so you will not set it up, so it will stay as 5 here, it will stay as 6 here, it will be, what was it, 7, right? 7 is here, so it will be ending up like this. I'm asking because I got a feedback from a friend. No, do I need to? I don't know, maybe. Except okay, any 3, I don't know, broke. Yeah. Okay, so seems like a valid thing. Maybe let's do it like that for I in range. Len nums. Nums I plus k minus 1 modulus len nums becomes a tuple of this, like this is the existing value, but this is the old value. So old value can, okay, let it be on the right side, left side, and the right value will be on the new value will be on the next one. So nums I, yeah, it's it. But there's only one option here. You have to do it if E, like this next, right? You can call it like mu E. Anyway, so let's make it less fancy. New E, new I will be like this. If new I is less than or equals to len nums, then this will happen. Alright, so as I said, it will be changing, but if it's overflowing to the next place, let them stay there. If this one is like overflowing to there, let it, we'll just set it up sorry, wait, what I'm doing? No. So this 0 will go to here, right? And it's indexed, so I minus k, I plus k, sorry. I plus k. I plus k. But here is the issue as well. So if it's here, you have to check another thing. If nums I plus k is tuple. The fancier way is instance tuple. there will be something else. Else, just do this, create this tuple. But if there's already a tuple there, which shouldn't be case, it shouldn't be the case actually. No, it can. It totally can. If the k is 2, for example, here, this will go to here, this will go to here, and this here, it will go to, it will see the tuple. It needs to set nums I to the first, the second one of the tuple there. So nums I plus k, the one, the second one. Sorry, but this, you have to take the old value and put it here to remember right now, and then you will put it to the correct place. Temp will be here, and yeah. Oh, it became very, very messy. I don't like it, but I will check it out in a second. Okay, let me try this one. Contest starts soon. Wrong answer. Okay, we can have a look at it later on. Let's have a 7-minute break and come back again. For the contest. So there is one problem, which is this disclosing contest related content in public discuss posts. But I'm actually, I think it's okay. Let me check. Contest, lead code contest in streaming. Okay, folks, I need to close this thing down. I don't know how long it stays, like it goes, but let's, I don't know, it will start in a minute. I need to close my screen like this. Yeah, it will be weird of me just looking into the screen, but anyways, let's go, and I will try to, yeah, I will not stream anything, mention about anything. Okay, it will take 1 hour and 30 minutes. Hmm. Hmm. Mm-hmm. Hmm. Oh, wieso? It's difficult. Oh, difficult. Yeah. Okay, I think I'm done with the contest. I will give up. I feel tired. I feel tired. I'm done. Where is it? I'm done. How can I? Okay. Yeah, I'm done. We'll have a look at the solutions in a bit. Oh. Can't focus on there now. It's so cold. I don't know why did I do that, but yeah. Let's take a break. All right, so we had a contest together with a friend, so I was talking about the questions. Let's go over it real quick. This was bi-weekly contest. I wasn't able to share my screen, but basically, so this was the first problem. It was a minimum number of flips to reverse binary string. I don't know why am I explaining this right now, but I just state this. And then this was the other one, total waviness of numbers in range. And there was also like the difficult of one, hard one of it, but the only difference was the numbers were big here compared to this one, right? So it was timing out there. So probably there is an optimal solution there that I was missing, and this was the other one that I failed to finish. So half of the questions done, which was good. I don't know how this discuss works. Yeah, that's me. Non-math contests. Okay, I like how critical it gets. So, yeah, I think I solved this one, right? Rotator, right? Was it the one that I solved? No, I think there was another one of it. Anyway, so I think I'll sum it up today, for today. For the stream. How many questions did we solve? Like I worked on 2 more in the contest. We can also like have another one. Like let's solve the one that I couldn't. What was there was a study plan that I was following. It was this one, I guess, and rotate array. I think, okay, this one didn't work then. Didn't succeed. Did it? Okay, it was failing. Okay, why it was failing though? So you're iterating over the nums. If I plus k is len nums, so if it's like within the place, within the list, so it doesn't overflow to the beginning. I'm checking if the value there is a tuple or not. If it's a tuple, I take the first value as temporary. It is the old value, right? And then I update its value to the second value in the tuple, and then wait, no. No. You should be checking the current one. If it's a tuple, the current value is a tuple, you do this. And then you update this. You put this value to I plus k, right? Yeah, because that is the old value that is supposed to go to the next one. If it's not a tuple, which means it's an integer there, so we'll just get it and put it here, nums I plus k. So it is guaranteed to be an integer at this moment, so you just put it there right away. If I plus k is overflowing to the new part, there you should be a bit more careful. You should do the new index, and then you need to update that index to have the nums I, whatever there is there. So I think this should work right now. And it failed. Why? All right. So one should go there. Apparently I'm doing something wrong. Oh, okay. You have to, like, after processing, what do you do there? Like, you're updating, but you're not, you also have to so you're updating nums I here, right? Here in this case you also have to update it. You also have to check if nums I, again same thing, is a tuple, this is for the else this is pass for now, and this should be like this. If it's a tuple, you have to, I think this is still needed for both of them, but I think you have to have something like this again. Temp, the old value, nums I, update with the new one, and then this temp will go to nums, new I, temp. Yeah, I think so. Let's go. Again, so somehow I put 5 here. Why? Like, I do 1, 2, 3. Where is 4? 4 is lost. Okay, so I go, so here is the input. I start from here, 0, right? I plus k is 3, which corresponds to this. So nums, this is a tuple now. So nums I plus k, so this gets an updated to 4, comma 1, right? And then it goes to the next one. This one is a tuple now, so this one becomes 5.2, this one becomes 6.3, and here we see 4.1, right? So here we see the index is 3, I plus k is 6, and so it will enter here. It's a tuple, so yeah, so nums I will be, and the first value it will be 4 temp, and then nums I will be equals to the second of 1, yeah, and then nums I plus k is 6, right, which corresponds to here will be I plus k, will be I plus k, whatever it is like 7 and 4, and then it goes on, goes on, goes on, goes on, goes on. Here I plus k here is like I is 6, k is 3, is 9, minus 1, 9 minus 1, 8, modulus 7, it's 2, new index is 2, which is this, so which is actually the correct place to rotate. So in that case, it checks if this is a tuple or not. Again, if it's a tuple, which is the case, it takes the old value, which is 7, yeah, it takes it away, and norms I becomes becomes 4, and new I becomes 7, and that's it. I don't understand why am I missing. So 7 is also gone, the thread is gone. I don't understand why. The thread is gone. Is it? No, I don't know why. Why? Why it's not working? It suggests me completely something else, and I'm too hungry to think about it right now. I don't want. Okay, let's stop it here, and we can continue later on from here. Bye.